as a reminder for those who may not have been able to join us in our last webinar last week, the idea of this webinar series was developed based off of stakeholder feedback. For the past couple of years, FHWA has been conducting a thorough review of our payment design program area, which included hosting 5 peer exchanges with state agencies. We had 1 listening session with industry as well as a national workshop. The first webinar of this series highlighted the outcomes of these efforts, and one of the consistent feedback that we received was the importance of education and communication to stakeholders such as yourself. So the idea for this webinar series was an outcome from these events, and the topics that we have developed in this series were topics of areas of interest that were brought up in each of the stakeholder outreach efforts. In addition, I would like to highlight that we're trying a new platform using Microsoft Teams. We usually use Adobe Connect, so please bear with us as we work through the kinks in using this platform. With that being said, before we get started, I would like to turn it over to my colleague Amanda McQueen, and she's going to run through some meeting logistics and basics of using Microsoft Teams.
Thank you, Heather. Again, I'm Amanda McQueen, a contractor with the Federal Highway Office of Infrastructure Mission Support Team. I have done quite a bit to help with a lot of this trialing, how to really make our meetings really useful within Microsoft Teams. For those who aren't familiar, this is sort of a rundown of what you see in front of you in terms of the platform. All the icons there, sort of a genie bar that you hover over in the middle of your screen so that you're able to see your mute buttons, both for your camera and your microphone. Those are very important because we do want to make sure that our recording comes out really great and that we're not distracting folks. So please, if you haven't already, please mute your microphone. And for the question and answers that will be prompted, please feel free to raise your hand using the hand raise button in that lower half of the participant tools list. And you can feel free to unmute your microphone and unmute your camera and show your video so that the presenters are able to engage with you as you have a question during the Q&A session. Likewise, you can also include your questions throughout the presentation to be addressed during the Q&A session in the chat pod or the conversation icon there. If you have any technical issues, please feel free to chat me in the chat pod, Amanda McQueen. You'll see here a few best practices. Many of you have been in this virtual environment for quite some time. But for those who haven't been to many of these virtual meetings and webinars, it really is nice to be able to utilize the chat pod for questions as they come up so that they're able to be addressed in turn during the designated Q&A session. If you do want to signal a specific presenter or signal me for any technical issues, please feel free to use the @ sign and start typing in the participant's or presenter's name. And again, use the hand raise function if you do wish to audibly and even over video share your question. If you have any connectivity and troubleshooting issues, please feel free to log out and log back in, as that is the very first solution. Unfortunately, I can't jump into your computer and fix your connection issues. So, you know, we're all trying to work in this virtual environment, but it is usually, if you're not seeing something on screen or if you can't hear something, try to just log back into the meeting room. Again, it will be recorded, so if anyone needs to review this together later, just let us know. And if you do need to log back in, try to use a different browser. Google Chrome, Microsoft Edge, and Firefox are preferred. Internet Explorer is sort of obsolete at this point, so please avoid using that. And if you do have Wi-Fi issues, for example, or need to use your cell service, you could use your smartphone as a hotspot or log into the meeting link, just forward it over your email to your smartphone. If you do have any questions or any major issues, feel free to chat me or email me at amanda.mcqueen.ctr@dot.gov. Right, back to you, Heather.
Thank you, Amanda. At this time, I would like to introduce our speakers today. First up, we'll have Tom Yu. Tom, you can turn on your camera so everybody can see you. Tommy is the program manager for pavement design. He will be providing a short presentation on FHWA's pavement design program area efforts. After Tom, we will have Austin Jarrell providing an overview of the current state of practice of life cycle cost analysis and pavement design. Austin is an intern at FHWA in the Office of Pre-Construction, Construction, and Pavements. Austin, you can turn on your camera too and wave. Additionally, he's a graduate research assistant at Marshall University. His presentation is going to build on some of the work that he was a part of this summer, working as a STIPDIG intern under my direction this past summer. Lastly, we will have Siva, and Siva is going to highlight some of the recent updates made to real cost, which will soon be available. Siva is a senior research civil engineer at FHWA's Office of Infrastructure Research and Design, where he is involved in conducting and coordinating research in pavement design, pavement management, and sustainable pavements related topics. Prior to joining FHWA in 2006, he worked at the Washington State Department of Transportation for 12 years, and the last 5 years as the state pavement management engineer. Siva, you can also turn on your camera and hopefully people are acquainted with you. With that, Amanda, next slide, and Tom, you are up.
Thank you. Hopefully I have the control. Okay. Thank you very much. Thank you for joining us today. I'll be presenting an update on FHWA's pavement design program. As Heather mentioned, I'm the program manager for pavement design at headquarters. So this is the outline of my presentation. First, I'll go over some vision and objectives, and then challenges, and then talk about our focus areas, and then our current and future planned activities. So this is a vision statement, US DOT's mission statement. And if you look at that, it says, the mission of the US DOT is to ensure our nation has the safest, most efficient, and modern transportation system in the world, which improves the quality of life for all American people and communities from rural to urban, and increases productivity and competitiveness of American workers and businesses. Now, what's interesting about this mission statement to me is that as an engineer, we often don't think about the social aspects of what we do, but it's very clear in this mission statement that improving the quality of life for all American people is pretty high on the list of priorities for our decision makers at the DOT. So now next I have a mission statement for FHWA is similar to DOT. The mission of FHWA is to enable and empower the strengthening of a world-class highway system that promotes safety, mobility, and economic growth while enhancing the quality of life of all Americans. So again, enhancing the quality of life is a significant theme in our statement. And again, as an engineer, this is not something that caught my attention before, but now that we're paying more attention to sustainability, it's certainly something that caught my attention. From based on these mission statements, what I can gather from those mission statements is the mission objectives of USDOT and FHWA was really calling for is a durable long life pavement that remains in good and excellent condition throughout the service lives. So how we do that is, I think, number one, we have to first demonstrate performance and sustainability advantages of long life, distress-free pavements. And then we need to provide some technical resources that'll help building these long life pavement, building and maintaining these long life pavements. And first, let me present some interesting data. This is from Washington DOT's Gray Notebook. This is data from 2012, a Gray Notebook 48. Gray Notebook is a publication from Washington State that presents Washington State's payment condition information. And I find that to be a very good source of information. I mean, all states have these reports. but I happen to like Washington State, the way that the information is presented. So so every state, I believe, most states have issues with budget. And what this is showing is, as a result of budget shortfall, in this period from 2011 to 2023, Washington State's estimate is there's a budget shortfall of something in the order of $1.5 billion. And the consequence of that, what they're projecting is from having something like 75% of the payments in the network in good to very good condition, down to only like 30% by 2023. And the payments in poor and very poor condition going from 9% to making up almost 40% by 2023. Now, if you look at more recent data, this is from last year. They published this in this. This information they do publish this quarterly, and their December report has the annual update on the payment condition. The last year's information, a much better condition than what they were projecting. But what's interesting about this slide is what this is showing is asset sustainability ratio. And what that is a ratio between the payment service life that is provided to the network in any given year, divided by the service life that's consumed in that year. Basically, every year we consume 1 year of service life. So if you have a 1,000-mile network, you're using 1,000 lane mile year of service every year. So if you're providing 1,000 lane mile year service each year, then you maintain status quo. Now, if you're providing less than that, what that means is your condition of your network is declining. So what this is showing is they were actually doing better over the years from 2014 to 2017. But in none of the years where that ratio actually hit the mark of status quo, which is they're defining sustainable range as 0.9 to 1.1. So what this is showing is, in time, your network is going to deteriorate because you're not adding as much life to your system as what you're consuming each year. And this is also showing up here in their condition report. So they're doing much better than their projections. So the lane miles in good to very good condition dropped from, it actually improved from 2011 to 2014. In the 2011, they had about 75% in good to very good condition. 2014, they had about 77% in good condition. But they are showing a decline of about 5% over that time period, and that is showing up in poor and very poor. Next slide. This is a little bit of a repeat of the previous slides, but it shows a fair, poor, and very poor condition. These are the condition levels that we're most interested in terms of how we maintain our payments. And a lot of interesting information here. What this is showing is for fair condition, they're showing that this is the most cost-effective range to do preventive treatments. So if you don't preserve your payment in this range and allow it to drop down to poor condition, what happens is it's going to end up costing you 1.5 to 2 times more. And if the condition deteriorates even further, it costs you something like 3 to 5 times as much as repairing the payment in fair condition. So I think we all acknowledge the benefits of payment preservation. And in principle, which the payment preservation really talks about keeping the payment in good payments in good condition. By the time it gets to poor condition, we're not really doing preservation anymore. It's more of a rehab. But that I think more of what we call preservation falls in these ranges. So we're not, those treatments are not as effective as they could be. And we have to go back and treat those payments more frequently as a result. So this is what we're used to seeing in payment design, in payment discipline. And I think this is part of the problem why we have this issue of declining network condition, because this is kind of given as accepted as a given in payment engineering that payments deteriorate over time. And most of what we do, most of our focus in payment discipline is dealing with distresses, how we measure it, what to do with it, how to rehab. We don't think about what if we build payments so that they don't deteriorate, they don't develop distresses. These seem like a very radical concepts. So what happens is this this isn't a present illustration of a payment condition over time, but this is also reflects what your network condition might look like. Okay. So what this is showing is for most states, we're well past the initial service period. So we're in second or third or rehab cycle. So often what happens is as soon as you rehab the payment, conditions start to decline. And in some cases, they decline pretty fast. And so oftentimes, by the time next rehab cycle comes in, the payment dips in a poor condition. And this is what we see in a lot of our payments. Now, the alternative, the long life approach, really it conforms to the preservation principle. We don't allow that we build a payment so that it stays in good structural condition throughout its life. So all we do is issue surface issues to restore serviceability and take care of any material issues. And in this way, now you have a chance of keeping your network in excellent condition throughout the service period. Okay, so when we talk about quality of life, so what can we do as payment engineers that affects quality of life for traveling public? Basically, what we can do is provide payments that doesn't require a frequent rehab, because every time we have to do a rehab, we have to do lane closures, which causes delays, and that is what quality of life. And also, if we have deteriorating condition, I'm sorry. Oh, let's see. I'm trying to go back on the slide, but apparently, I'm sorry.
I can help do this.
Okay, I'm
so
sorry.
Go back to.
Could we go back to that slide that I was on? Apparently, I can only go. Oh, okay. Let me see if this. Okay, I got it. Thank you. I was clicking on the wrong key. Okay, so if we have this situation, then we do see deteriorating condition. Payment becomes rougher, and we have to shut down fairly frequently for rehab. So this is a desirable way to maintain payments, and we can do that with long life payments. And this is another schematic illustration of how this works. And I believe today we're in this region 1 where keeping the payments in good condition requires constant attention, and it costs a lot of money. So every time the budget, we fall short on budget, the network condition starts to decline. The alternative is if we have a long life approach, then it actually is costly to let the payment deteriorate. So what we do is we try to keep the payment in good condition, and it's a much more stable way to maintain payments in good condition. So this is the approach that we're promoting, and the challenges and solutions. To me, economic sustainability is the biggest challenge that is facing highway agencies today. I mean, we have to have enough money to be able to provide payments in reasonable condition, and this is what we struggle with. And if we have to keep rebuilding our payments, sooner or later, I don't think we'll be able to afford to do that. So I think that the way to really truly change that is to adopt this long life payment approach, because it is, I believe, over the life of payment, it is the lower cost option. And not only that, it's not just the payment cost that gets in the way of providing good payments. If we have fewer projects to deal with, I think that'll be a lot easier for DOTs to provide payments in good condition. So if we have a long life payment that doesn't require as much rehab, then I think sustainability is improved automatically. Now, payment managers are well aware of these concepts. So the even bigger challenge than adopting this concept is we have a very extensive network of payments. And if we spend resources reconstructing, say, a short segment of your network, then that impacts what we can do with the rest of the network. Then we wouldn't be able to provide as much coverage. So that is the biggest challenge we have. But we do major rehabs. We do reconstruct some pavements. So the opportunities are when we have to do reconstruction or do major rehab, we need to start thinking in terms of providing a long life pavement, a more conventional shorter life with a deteriorating condition over time kind of model. So what can we do to achieve long life payment? I believe there are three key factors. We need to have effective structural design, and then we have to have durable material, and then we have to have quality construction. And I'm very happy that we're addressing these in our office. We have all different teams focused on these areas, materials teams, focusing on performance engineered materials that is addressing these issues. And we have also quality assurance group that is focusing on improving construction quality. So my area is on effective structural design. And effective design, to me, I think one of the issues we have is we don't pay enough attention on foundation design, because we tend to focus so much on structural analysis, and we keep trying to, for example, for Pavement ME implementation, we pay so much attention on trying to calibrate, recalibrate, and improving our model. But I think at some point, I think we might be approaching a point of diminishing return, because you can't really refine the structural model that much. I mean, at the end of the day, if you think in terms of pavement thicknesses, we're not going to change that so much by improving these models. We'll still probably most likely have the similar ranges of thickness for concrete pavements. For highways that might be anywhere from 8 to 12 inches. And we might have similar ranges for asphalt pavements. But one of the reasons that we tend to overlook foundation is that we design pavements based on pavement response. And foundation, for the most part, especially for concrete pavements, don't really show up on this design analysis because they don't affect pavement response so much. But what is important is what happens to the pavement over time. So what is most important aspect of foundation design is the foundation layers has to stay, they need to retain their integrity throughout the life of the pavement, so we don't have localized issues. And that's the part that to quantify the benefits. So we tend to not pay as much attention to that in the US. But if we are looking for long life pavement, I think that's where we have to put our resources in. Now, this is one of my most favorite subjects, the Roman road. And to me, one of the most impressive part of this Roman road is what is underneath. If you look at the cross section of the Roman road, it's amazing how much attention they pay to the structure itself. They have various different layers, and they have about 3 foot of material for these rows. And these cross sections are pretty similar to what Europeans are building today. There's the only difference of maybe a couple inches of total thickness. So what they built is pretty much like, so this middle layer, there's a layer that is kind of like a stabilized layer, lime stabilized. So what they built is kind of like an inverted pavement. But the key point is they paid attention, and this wasn't done by accident. One of the things they wanted to achieve, that these Roman roads were built by regions, by tax collectors, and they could collect money to build it, but they were concerned about being able to maintain it. So they wanted to build the roads to last, and the result is what we see today. So this didn't happen by accident. They planned it, and they put a lot of emphasis in foundation, and I think that's what we also need to do. So for pavement design program activities, our current emphasis on improving foundation design. So we have some activities that's looking at foundation design for concrete pavements. That was done under concrete pavement IDI contract, so that was just focused on concrete, but we'll also do that for asphalt pavement. And we have an active contract looking at failure mechanism for pavement foundation, just documenting what sort of bad things can happen if you don't provide adequate foundation. And then another project looking at the feasibility of utilizing intelligent compaction equipment to ensure uniformity and quality of pavement foundation. The focus of this project is to making sure that we have good construction platform before we actually pave, because I mean, one of the things that we like to do is have some sort of rolling deflection measurements. But then what occurred to me is that if we were to do that later in pavement life, what it'll really highlight is the areas that were probably not good to begin with. So the focus of this project is to identify those areas up front so that we don't have these localized bad areas. And then the next one is inverted pavements, because I believe that is a very efficient structural system. So we're looking for other innovative ideas for pavement solutions. And for future, again, we have a very extensive network of pavements. So pavement evaluation is an important subject, so we'll look into that, how we can identify projects where we need more than just a surface rehab. And then the design and construction of pavement foundation guidelines, the things that, the best practice guidelines, and design and construction of inverted pavements. So those are the things that we're looking at, and this is again emphasizing, unless we change the way we do things, we're likely to get into this area that is really difficult to overcome. When we start to getting into so much of a network, getting into poor and very poor condition, that's going to be it'll be very difficult for states to continue to provide payments in good condition. So that's what I have. So I don't know if we do questions now or later.
Hi, yes, so I think Heather Dilla is having some connection problems, so I'm going to step in for her. But yeah, let's take a pause and see if there are any questions. You can feel free to raise your hand and unmute yourself and ask a question, or you can type a question in the chat pod. So if anybody has any questions, feel free to ask them now. And again, you can enter in the chat pod anytime during the presentation. I'm not seeing any hands raised, and I'm not seeing any questions in the chat pod at this time.
Okay, thank you.
So, oh, couple coming in. There's a question. how does Washington DOT define condition index? Good, fair, poor?
I'm not sure. I'll have to look into that, but I would imagine that's similar to the measures that we typically use. It might be based on actual physical condition, or it might be based on ride.
Okay, and then one other question or comment. Thank you for bringing up the importance of a durable foundation.
Oh, thank you.
I think for the Washington question, it's based on a rutting, roughness, and a pavement structural condition index, which is a combination index. And any one of them being in the good category is good, but they don't, in terms of very poor is 0 to 20, 20 to 40 to 60, 60 to 80, and that way, in 0 to 100 scale on pavement structural condition, which is based on cracking.
Thank you.
It's based on, oh yeah, thank you.
Yeah, thank you, Siva. One other question. What about perpetual pavements?
That's an excellent question. I like that idea. Essentially, when we're talking about long life pavement, those are the kind of structures that I'm talking about, but I'm not so sure we necessarily address foundation issues in perpetual pavement. And the other thing I might mention is that for the most part, we don't build perpetual pavement, but I think almost all states are maintaining their payments as though they do have a perpetual payment, because when you talk to state engineers, they say, well, all we do is mill and fill. So that's like just doing a preservation of a structure that is really not a perpetual structure. So this is why we see that, for typical life cycle planning purposes, we typically assume the first overlay is needed at maybe 15 years or so. Next one, we typically assume a little less, maybe 10 to 12 years, and the subsequent overlays even less. So what that's really telling you is that the payment structure is deteriorating, but we don't acknowledge that or deal with that. So but to me, this is a significant issue, because if you're only getting 8 years out of an overlay rather than 10 years, that's costing you 20% more. That is very significant.
And one more came in. What design life do we expect for the long life pavement?
I'd hate to put a specific number on design life, but I think if you were to design for, say, 40 or 50 years, and design so that you wouldn't see significant distresses, meaning less than typical model error, then you will end up with a structure that is more or less perpetual pavement, and then you would just have to address the functional issues.
Like labor pains. They will close
okay, we'll take one more here and then we'll move on. We have a lot of pavements that are rated a poor PCI, but still have decent ride quality. Do you think we should research?
Amanda, it seems like we have, is it possible to review it all and try? Thank you. Okay, Jen, what was that?
Oh, okay, I'm sorry. Yes, we have a lot of pavements that are rated a poor PCI, but still have decent ride quality. Do you think we should resurface?
No, I think, to be sure, the cheapest way that you can maintain a pavement is doing nothing, okay? So if you have a serviceable condition, the cheapest thing you can do to a pavement is preservation treatment, mostly because they're cheaper. Another interesting information that came out of Washington DOT is they show that the chip seal is it costs one-fifth as much as doing hot mix asphalt. They only last half as much, but since you're getting 5 times, it's one-fifth as expensive, there's a cost-benefit ratio of 2.5 times advantage. So, I mean, whatever you can do to keep the pavement going, I mean, there's nothing. The question is, how does that impact your traffic? If you're in a rural area where the traffic management is not an issue, you could keep the pavement in that way, and that might be perfectly fine. But if you're in an area where congestion is a major issue, then that's really not a sustainable solution.
All right, thank you, Tom. And again, feel free to keep your questions coming in. You can type them in the chat pod, and we're going to move on to the next presentation now. But if you do have any questions, again, type them in the chat pod, or after the presentation, you can raise your hand. Okay, so let's move on to Austin. You're going to present next.
That's right. All right, everybody. My name's Austin Jarrell. I'm an intern with FHWA working with Heather Della in the Office of Pre-Construction, Construction, and Pavements. Additionally, I'm also a graduate student at Marshall University. Today, I'm going to be presenting on the current state of practice for life cycle cost analysis with respect to pavement design. Next slide. So, before we begin, here's the helpful list of acronyms for terms that will be used throughout this presentation that you all keep in mind. Next slide. So, life cycle cost analysis at its core is a technique that provides total costs for competing design or preservation alternatives, each of which is appropriate for a transportation project and provide equivalent benefits. So today's presentation is the state of LCCA in regard to pavement design. And for pavements, LCCA considers agency costs and user costs for overall cost estimation. Now, according to the recent discussions at the Pavement Design Policy Peer Exchange in 2019 by FHWA, 39 out of 52 states have LCCA policies for pavement design. Next slide. So, state agencies have a long history for using LCCA to inform pavement design. LCCA analyses are useful for project level analysis and for comparison materials, rehabilitation strategies, work zone strategies, and alternate bidding. And I'd just like to remind everybody that if any point during this webinar, any of the language that I use for LCCA seems unfamiliar or unclear, please refer to FHWA's Life Cycle Cost Analysis Primer with the following link here on the slide and in the chat box. So this primer includes general principles for LCCA and isn't specific to LCCA use in pavement design, but it's still a really useful reference for our purposes. Next slide. So it's best practice to have established procedures for conducting pavement LCCAs. These procedures would include additional details, 1 through 5, along with detailing when the LCCA should be conducted. Now, these procedures are representative by step 0 in this slide, which is organized. It's made up of establishing an LCCA framework, determining when you're going to apply it, and establishing a project scope. Now, some of the information that we're going to discuss in further detail in this presentation, such as discount rates that are used, analysis periods, these kind of things are often defined in an LCCA framework as a part of this step 0. Now, steps 1 through 4 are to establish alternatives, determine activity timing, estimate costs, and the computation of life cycle costs. Step 5, finally, is the last step of the process, which is to analyze results and to use those results as a decision support tool to move forward. Next slide. So before we provide updates, we need to establish the references that are informing this presentation along with our pavement design policy peer exchange sources. These references provide insight as to how states have been using LCCA. So during the pavement design policy peer exchange, there was some discussion on current LCCA practices, which we then used to provide updates to some existing LCCA data. And again, we've included historical data to show current trends and how LCCA is applied. Next slide. So the first aspect of LCCA that is of interest is the range of factors that trigger the requirement of LCCA for pavement type selection process. All trigger criteria mentioned here in the slide could be in step 0, as was discussed previously in slide 7. Now we can see that trigger criteria from South Carolina 2006 include truck percentage, average daily traffic, pavement type system, structure, and cost, which is the highest reported trigger at this point. Now, because stakeholders may consider these trigger criteria in step 0 and due to prolonged construction periods, escalating materials cost, and change in traffic conditions, updating the LCCA data and rerunning the analysis are becoming very important issues to consider for stakeholders. In conducting LCCA, it is important to be aware of the fact LCCA has a shelf life. And in some cases, the data used in the analysis might lose its validity even before a decision is being made. The cost of materials, life of the design, and change in traffic conditions really needs to be considered for some additional criteria that should trigger the requirement to reconduct an LCCA if necessary. Next slide. So as we continue throughout the presentation and discuss LCCA details that are more technical in nature, again, I would remind everyone that if anything is unclear, please check out the FHWA LCCA primer and follow along. Now, transportation assets are constructed to provide service for long periods of time. A service life of an asset is a period of time that an asset will remain open for public use. More often than not, design alternatives for transportation assets have different service lives. To account for this, an LCCA study uses a common time period to assess cost differences between alternatives so that analysis results can be accurately and fairly compared. So, and it's important to mention here that if someone would allow varying analysis periods among alternatives, that would break the fundamental assumption of an LCCA, which is that all alternatives produce equivalent benefits. Usually an analysis period in an LCCA is long enough to contain initial construction or a major rehabilitation and at least one subsequent rehabilitation action for each alternative. Now, examining the data here from AASHTO 2007, we noticed that a majority of representatives indicated that their LCCA analysis periods were between 30 to 39 and 40 to 49 years. Next slide. So compared to the information from the previous slide, the data here shows a clear shift in analysis periods for LCCAs for pavements. We can see now that a majority of states and territories in analysis use analysis periods of 40 to 49 and 50 plus years, which marks a clear shift to longer analysis periods considered. Also, you might notice the variable metric there. I would like to note that that specifically is included to account for agencies in analysis that indicated the usage of different analysis periods for different types of projects according to their pavement design policy. Next slide. So this is the portion where we're really getting into things that could be considered in step 0 of an LCCA framework. Now, the FHWA Lifecycle Cost Analysis Primer recommends the use of constant dollars and real discount rates. Real discount rates reflect the value of the true value of money over time with no inflation premium. Now, when estimating future costs of transportation projects, discount rates play an important role. Now, probabilistic approaches are often best suited for conducting an LCCA when there is some inherent uncertainty in the variables. And I'll explain more later about deterministic versus probabilistic approaches. However, basically what this data from South Carolina 2006 reflects are various listed discount rates used in LCCA, with the majority chosen to be 4%, which isn't unusual by any means, and other considerations such as how many states conduct sensitivity analyses and probabilistic approaches to examine their chosen discount rates and account for uncertainty. Furthermore, I would like to note that several state DOTs use the Office of Management and Budget, OMB, discount rates when selecting their discount rates. Next slide. So comparing to the last slide, we can see the vast majority of states still list 4% as the discount rate used in LCCA. While the PDP peer exchange did capture discount rates used in LCCA to a certain extent, a review I completed personally of 33 states' pavement design manuals yielded the following information for discount rates for LCCA. Now, the reason that these pavement design manuals were reviewed by me personally is that FHWA is still in the process of reviewing the pavement design policy peer exchange itself. And because of that, its technical guidance for pavement design, including LCCA, is still under review. So FHWA's current guidance is still to go by discount rates set by OMB if you're not sure what to use. An online search of OMB discount rate will provide the information that you need for that. Next slide. So during the LCCA process, it is important to time activities in a way that maximizes economic benefits. One important aspect of activity timing actually is the time to the first rehabilitation for an alternative. So this would occur after an initial construction or major rehabilitation in most cases. So this is another aspect that's often included in the LCCA framework, which is step 0 that I mentioned in the beginning of the presentation. So from South Carolina 2006, respondents listed the average time to the first rehabilitation of flexible and rigid pavement design alternatives. So it's also important to note that the standard deviation for each pavement type for the time period is also present. So for flexible pavements, there's an average life to the first rehab of just under 15 years. For rigid pavements, it's about 23 years, and the standard deviation for flexible is just under 5, with rigid being at 5 years. Next slide. So similarly, an important piece of information is the life of the first rehab for any given alternative. So again, looking at the South Carolina 2006 reference, we have the average life of the first rehabilitation for flexible and rigid pavement design alternatives. And we also again have the standard deviation. So again, for flexible pavements, the life of the first rehab average is just under 12 years. For rigid, we have it at 14. And then for the standard deviation for flexible is at 2 years. And for rigid, we have that right above 4, looks like about 5 years. Next slide. So again, going through this, the inputs into an LCCA framework, we need to talk about agency costs next. Agency costs are those that generally arise from initial construction, periodic maintenance, and rehabilitation activities. Agency costs play a key role in the life cycle cost determination for any given project. Now, this figure shows the results from the South Carolina 2006 reference, indicating the typical costs that are included in the agency costs for those conducting LCCAs. Based on this data, it is evident that all respondents consider the initial construction costs and rehabilitation costs in analysis. However, there is a lack of consensus on the inclusion of other agency cost elements, such as traffic maintenance, engineering, construction management, among other things that are incurred by the agency over the analysis period. Next slide. So from the peer exchange, states and territories in analysis that complete LCCAs as a part of their pavement design policy weighed in on whether the following types of agency costs are considered: maintenance, rehabilitation, and initial construction. Now, most states and territories in analysis indicated that primarily initial construction and rehabilitation costs were considered as agency costs in LCCA studies, while noticeably less respondents indicated that maintenance costs are taken into account. Next slide. So now that we've covered agency costs, we need to transition to user costs. User costs are those that are incurred by the traveling public. These often outweigh agency costs and are the costs that the public would pay themselves. It is recommended that agency costs and user costs are kept separate in analysis, by the way. And user costs of primary interest in LCCA are vehicle operating costs, travel time costs, and crash costs. Now, user costs are typically influenced by the timing, duration, scope, and number of construction and rehabilitation work zones for each project alternative. Examining information from past references and the PDP exchange, we can first note the number of states and territories in analysis and the percent of states and territories in analysis applying user costs. So for South Carolina 2006, 40% of 35 total respondents indicated that user costs were applied. Additionally, for AASHTO 2007, 29% of 21 respondents indicated that user costs were applied. And finally, for the PDP peer exchange, out of 52 respondents, 27% of states indicated applications of user costs according to their pavement design policy. Next slide. So during the PDP peer exchange, states and territories in analysis indicated that user costs considered are time or user delay and vehicle operating costs. In this case, 11 agencies indicated that they considered time or user delay as a part of their LCCA, and 7 agencies indicated that they used vehicle operating costs in their LCCA analyses, respectively. Next slide. So one of the a common step taken for any LCCA is to facilitate the computation process. Many different tools are used. FHWA has actually developed a tool called Real Cost, which many of you I'm sure are aware of, which is currently undergoing an update. And actually CEVA is going to be highlighting some of the important changes shortly. But as this chart states, many states are obviously very comfortable using Excel, and that's actually great because Real Cost is also an Excel-based tool. Now, a few states have customized tools specific to their program policies, which can be represented by the combination category. And and some states utilize tools in a other various category. Next slide. So now this is where we get to deterministic and probabilistic approaches. We know that those are the two main approaches used in an LCCA. The deterministic approach assigns each LCCA input variable a fixed discrete value. Collectively, all discrete inputs are used to determine a single life cycle cost estimate. Although this has been the traditional approach to LCCA, this approach often fails to appropriately address uncertainty associated with present value estimates. Now, the probabilistic approach allows the value of individual analysis inputs to be defined by a probability distribution. Through a sampling process, any given alternative values are randomly drawn from input variable distributions and are then used to compute single forecasted output values. Now, fundamentally, what you need to know is that the probabilistic LCCA accounts for uncertainty and variation in individual input parameters by producing a probability distribution of present values for each project alternative in analysis. Now, once this is done, these can be compared with projected present values for each alternative and then used as a decision support tool. South Carolina 2006, the vast majority of states indicated that deterministic LCCA approaches were utilized, with notably only one response indicating a fully probabilistic approach, with 3 in combination. Now, as a part of our PDP peer exchange, we captured a clear towards probabilistic approaches to LCCA as required in respective state pavement design policies. And we can see now that 4 states list that they're using probabilistic approaches. We have still 3 in combination, but we're seeing a reduction in deterministic approaches. And this is exciting to see because this marks that states and territories are moving towards LCCA approaches that better capture uncertainty and are better for all stakeholders involved. Next slide. Yeah, you can see the PDP information here. Go ahead to the next slide. All right. Now, I'd be remiss if I didn't mention concerns with the LCCA process. LCCA can be quite a challenging method, as all of you know, to properly complete. And there are many that in our PDP peer exchange that honestly are consistent through all the other references in this study. Concerns include reliability of inputs, lack of training to recognize individual input importance, material prediction in a period of rapidly fluctuating prices, lack of long-term field performance data for newer design and materials, and also confidence in triggers for conducting rehabilitation and maintenance activities. Next slide. Now, and again, these are just a few more continued concerns that we found, which are common. Industry concerns over performance lives, maintenance frequency and residual value, and also lack of confidence in the overall LCCA results. Now, I'd just like to say on this note, as FHWA continues to review the pavement design policy, they will be considering these concerns in developing future program efforts. Next slide. So all of our contact information is noted here with mine in the bottom right corner. If any of you have any additional questions after this webinar series that aren't answered, please reach out to me or anybody else here. I think Heather mentioned that we're going to hold off on questions until the end of SEVA's update. So for that, I'll go ahead and turn it over to SEVA for an update on FHWA real cost. Thanks, everybody.
Thank you very much, Austin. If I can get the control, Amanda.
Sure, you can just click the screen share button and it'll automatically.
Sure. Okay, sure. So, can you see the Excel worksheet? Thank you all for attending this webinar. And I will be very brief. We have been updating real cost, the Lcca tool for payment design that Federal Highway has developed almost 20 years ago. It has gone through a number of updates, but there were a few things that we wanted to focus on in the next version. And so the key, again, the look and feel kind of is similar to what you might have, if you have your real cost in the past, you will notice. So the switchboard is there, and there's a noise in there. Okay. Amanda, I think there's some background noise coming up. I don't know from whom, if you can mute. Okay. So the switchboard is there, and most of the input and analysis functions remain the same. The primary enhancement is that some of you might have found out that the current version of real cost was only compatible with the 32-bit version of Excel. It did not work on 64-bit version of Excel. Again, this is about the Excel version, not the operating system, because most operating systems are now 64-bit anyway. So this updated version will be operational on both versions of Excel. Another enhancement is that in the past you have to, when you are setting up the real cost, you still have to install it, which means that you need administrative rights to first install the program. But once you install, you don't need the administrative rights to use the program because it's an Excel worksheet, but there's a library that it uses that needs to be registered. But most of us no longer have administrative rights to our computers, so that has been somewhat of an issue. The new version have to install it. You just call, there will be a zip file that we will post it on the website. You the files and folders and put it, copy it to your folder, and you are ready to go. And then also that you will see that look and feel being different, just modernizing the color scheme, as well as it's made fully 508 compliant. So that's a major requirement from Federal Highway, and I think some of the state DOTs also may be implementing implementing 508 compliant in there. And so in terms of other enhancement, we have incorporated few calculators, for example. Or, one of the things that you have as part of using real cost, particularly when you are using, incorporating user cost, is that you have to have an estimate of AADT, or annual average daily traffic, that is being kept because you started a very high traffic volume, have a growth rate, and a 50-year analysis period. You may, if you don't cap the AADT, it will grow to be basically the system cannot handle. But what will happen in those cases that there's going to be capacity improvement, but that's not part of this LC, the current you are conserving. So we had to be realistic in terms of how much the maximum AADT within the current lane configuration can accommodate. And so we, in the past that there wasn't an easy way to compute that, but we have implemented just a calculator that where you can say, okay, if your agency is willing to tolerate a maximum of 8 hours of, congestion or queue traffic, then what would be the maximum? And the assumption is when it grows beyond that, either the demand is going to, the growth rate is going to flatten off, or there's going to be, capacity improvement. Similar to there are few other calculators we are implementing to help with some of the input that you might have been, hard to come by. And so those are some of the enhancement in terms of real cost. And, the primary thing is that being able to work on 32 and 60. It includes 4 worked examples, so kind of a very realistic case studies, 3 for payments and 1 for bridge. Even though real cost is primarily targeted for payments, it's equally applicable to bridges, and so we and some states have used it for bridges, and so we have incorporating example which is already in the previous user manual, but it's being just updated. In addition, there will be a section on tips on customizing real cost. Again, the reason that real cost is flat form, on Excel flat form, is that we provide the opportunity for agencies to customize it. So particularly when if you are adapting probabilistic analysis, being able to use bid item level variability, because when you are looking at agency cost, you have you don't have a probability distribution for your agency cost, but you do have historical bid cost data that you can develop distribution. And so if you can apply the variability in the bid item level and then roll it up to the agency cost, so that will be there will be examples showing how that you can do in the user manual, as well as custom outputs. So again, if you are doing probabilistic analysis, in LCCA for payment design or anything, it's not really the individual alternative cost, that the life cycle cost, that's interest. What is of interest is the difference in life cycle cost between the two alternative, because that's what you are using to determine, which would be the most preferred alternative. So being able to look at the difference in life cycle cost as an output and being able to develop distribution basically collapses two, having to deal with two distribution collapses into one, and it's much easier to handle. So those are some of the, things that we are working on. The tool tested right now. If any of you would be interested in testing it, please send us an email or put your email address in the chat pod. But we are hoping to post the final version sometime next spring. So with that, I will turn it over to Jen, I believe, for any question on.
Yeah. There is one question in the chat a couple questions in the chat pod, but the first one, has the user cost been corrected for the user cost with all the lanes open during construction? There was a glitch earlier where the LCCA analysis computed user costs with all lanes open. These costs shouldn't be contributed to the construction and should be subtracted out.
Yes, it has been, maybe, real cost has, from the very beginning, we recognize, because when you have, queuing occurring or congestion during normal operating condition, you throw in a work zone, it just makes it even more, miserable, and that user cost, when you compare that one, it will be significantly, user cost. But that's not that total user cost is not directly related to the work zone. So we do use the delta user cost, which means, calculate the user cost under normal operating condition, and that is subtracted from once you put the work zone, so that only the user cost induced by the introduction of the work zone is included in that. There is a checkbox in the option in there that you can turn it on or off. Normally you want to turn it on so that it is considering only the delta user cost. Hope that answers the question.
Okay, and another question regarding variability around costs. Agencies don't have variability data for total cost on a given project. What they have is variability data on material unit costs. What is needed is where I can put in different pavement structures so that I can use the data on unit cost to capture the true variability. And the only way to get that distribution is to look at the project level.
Yes, I think that's what I mentioned in terms of customization. Actually, some of the state, I believe Washington State. So the main reason for us to going into Excel platform is that you can incorporate your agency cost computation. I think most EOTs use Excel for computing project cost, rolling up your bid item and quantity. So you can incorporate that worksheet into the real cost and then roll up the agency cost from the bid item. So yes, you can do it. It's some state, using real cost, and it has been done. Some of the states have already been doing it. One of the things that we failed is we didn't clearly provide tips or help in terms of how to do it. That will be part of the user manual, so you will be able to easily incorporate that.
Okay, thanks. And then there was one other comment. It was addressed to you, Siva, but I think it was in Austin's slide. Do you know how many users or agencies are currently using real cost?
I think Austin had the slide, I believe 11 based on the look at the Austin. Yeah, go ahead, sorry.
Yeah, I can answer that in the scope of our pavement design policy peer exchange in 2019, which is again still being verified. But according to what we found from states in analysis, according to their pavement design policies, 11 states use real cost, and then the next category is 29 states using Excel spreadsheets, 4 use a custom software, 1 use Darwin, and 2 use a combination. And again, that's according to pavement design policy. Actual usage may vary.
Okay, thank you all of the presenters, and I'll just pause one more moment. If anybody has any questions, you can either raise your hand or you can type in the chat pod. Heather, are you on?
I'm here.
Okay. Didn't know if you wanted to close us out or you want me to cover that?
No, I'm back.
Okay.
So thanks again for joining us for the webinar series. For those of you, I really apologize for some of the technical glitches today.
We will have recordings for this that will be available as soon as we close out this email. So on the, not on this slide, but the next slide, and I won't reference it now, but there'll be a survey and you can put your email address in the survey, and then that way we can make sure we can get you out a copy of the recording or slides. Just a reminder, the next webinar will be December 15th, and it's going to be an update on the pavement preservation, the LTPP program, and friction and safety. So please join us in that webinar series. The link from now on out will be the same link, and I will remember to send out reminders the day of the webinar. So hopefully you guys will then also have the same link. So this will be the same room. If you guys were able to make it here now, we'll also use the chat feature. So you should get pinged when we're getting ready to start the webinar about 10 minutes before, so that you should reminder as well. The link to the survey is the Menti link shown here. Sharon will type that in or post it in the chat for you to access. Again, please enter, fill out the survey if you have a chance, and if you want copies of the slide or PDH certificate or references to the recording, please make sure you include your email address there. Those that have put it in the chat, we've also caught that too. So we've got, you don't have to do both if you put it in the chat. In addition, we are trying to improve our way of communicating with you, and so it won't be just emails. We're setting up a GovDelivery email account, and so Sharon's going to put in the chat the link to sign up for our newsletters. They haven't started yet, so don't worry if you haven't received anything. But again, if you do want to make sure you receive any updates on webinars or what products are being lately published, that's what that newsletter will be announcing. And so that's a good way to stay informed with FHWA's pavement and materials activities. With that, if there's not any other questions, that's all I have. And thank you again for joining, and we'll see you in a month. Happy holidays.